In this scene here, I want to show you something that we can do with camera mapping. And the major theme in this episode here is all about how can we use, or not use even, global illumination for those scenes. Because when we take a look to a scene like this, it looks pretty much like we film in the city. And of course, that is the illusion that we want to create. And even the reflections are here and not faked, and everything works nicely. As you can see, it moves in the reflection. So the illusion is there that we have a complete set here in front of us. And how about putting elements in the air and have global illumination working on them? So we have from all these parts here the light on this object. That is a question that I have seen more than often, and I will fill in some concerns that I have about something like that, and maybe then the question next time is already answered in most cases. Okay, let's get started by examine this scene here, what we finally have. So this is the scene as seen just in the preview, and when I render this scene, I get here exactly this preview here. So we have here even on the top a little billboard just to fill in some maybe boring part on the way. And as you might notice, we have everything here in the scene that we need. And when I move here with the camera around, I get even more from the background here. This building is visible, and I have in the far away background here, yeah, not really a skyscraper, but something in that manner. And of course, we go here from one building to the next. You can see here I have some more definition in it because I go very close to it. I have all these parts here just to give a little bit more. And the further away I go, for example in this building, I have not even the windows cut it out. But what I have done here, just to fill in some ideas, this image was shot closely to where the camera, the render camera, is at the moment. So we don't need to get here little polygons in it to see a little bit more. This wouldn't show up when we move the camera as shown before. And only when I go with the camera on the other side of the building, I would see maybe on the left side nothing, and on the right side I see a frame. That would look maybe a little bit weird. But the closer we are with the camera, the better we are off. Okay, that's not the scene here. Let's have a look what we have here finally in the scene. And I scale this up a little bit. So this is the billboard on the roof. Here we have the billboard and the parking lot on the right, the opening one. And this billboard here is the one that we see on the end. You can see how the camera works here. That's normally a huge camera move, and it needs urgently to be done with a huge crane. So that means you have to rent the whole parking lot at least for one day. It's at least one work of preparation, and to get all the licenses and all the unions in place to have this shot done. So this is a typical camera mapping shot, because the budget for a shot like that, where you wouldn't see so much difference, is maybe so far away from that what it would cost here in cinema to do that, that there's no big concern just to do it in this way as I have done it here. So this is here already the whole scene. And when I go here back to my main view, go one time here along, so you get more savvy with what we have here. And I go to my editor camera in this window here. Then you can see here already that we have not so much in the scene at all. This is all we need. And from my understanding, camera mapping means that we reproduce from photos something that gives the illusion as if we had the camera in the scene itself, with the option to move then this camera here in the way we want to have it. And of course, without the pressure to be on set and do it in the first or in the second or in the third take, because every hour costs a large amount of money, of course. So, and when you go then here into the scene, we do not have a lot of stuff here inside. this is only for the reflection there, this is for the background, and these little guys here are just to fill in when the camera would go between the street here, just like there. So it's only the minimum that we need, maybe a little bit on top of that to have some security in it if I decide finally to move the camera differently. But the main idea is from one billboard to the next billboard, and everything between should work. So what we see here is normally eaten away with an alpha channel. And so we have here only that wall, and here the facade with nothing underneath. The tower is only built as needed, and you will see immediately what I have in mind with that. Even some details which wouldn't work here from this perspective, like all these columns here, and it looks completely distorted. But in the moment I go here back to my main camera, it looks just right. It's just in the way it should be, because the closer the capture camera for the projection camera was to the render camera, the less I have to integrate geometry to get this out again and undistorted. And distorted means here the perspective distortion, of course. So even these fine details here look just right, and I have no problem to move the camera pretty far here without losing believability in it. And it's only just, I think, 6-7 polygons here, just pulled out and done. Okay, so I think that answers already the biggest question: can we do this? And I want to go now to my chalkboard and go through, I think, 4 or 5 ideas about the whole subject of global illumination and camera mapping. So the first idea is, of course, the light direction. When we have a light source, like the sun, for example, and we have here just a little box in front of us. When we photograph this box, we have no idea where the sun is. But all the sun is going here into the front face, and we get maybe here just shadow on the side. Then we take this on a cube in Cinema 4D and project it on it. All we have then is an image projected on 2 sides maybe, or 3 sides, as we have discussed it so far. The sun by itself is not there. And so anything that would go now here exactly in front of it, let's say between the sun and the box, would first cast no shadow here. That would be the first thing. Then we have no sunlight here. We go to that point in a second. So we wouldn't have any light directly from here, and we would get maybe a little bit light from this side here, but anything else that is maybe in the background or far away will not deliver any light to it. So we have maybe a problem, especially when we think about the sides that we have not at all, because we don't need it from the camera. We would have to photograph the back side as well. And then we take an image here and we create the sides on the back, which means pretty much double the amount of work already. And then we start to find something very, very weird, because when we think about a surface, and I take now here just one little stroke, and we have the sun here, then we think the sun has maybe only one ray here, just to simplify this. The quality of the surface here can cause that we get maybe only one ray out, when it would be a mirror-like one. If that is really rough here, like a stone, then we get a lot of light here out of that. So it rays in all direction and scatters, so to say. An object that is maybe here now gets a different light than an object that is here. Similar to that, we have, of course, any kind of information that changes with the angle of this object here, where it is. And similar to that, we have the camera photographing this, and this camera has only one angle here to the surface. And that means it has one very specific relationship to the light source. In the moment we have an object then here, it would have a complete different relationship to the surface than the camera had. Because when you think about something reflective or highly absorbent, it would have a different way to get the light from here to this object or to the camera. So there's a big difference in it. That is one major point to consider, that the light is always dependent from the light source that illuminates it and the surface quality, how the light is finally then absorbed or reflected, refracted, or just scattered or whatever. And that makes it, of course, a little bit difficult to say we have just one camera here. We shoot this thing and whatever position we take, it will not take the position all the time from the object that we want to move maybe around here in the scene. If we have that stationary, that would be something different. And then the whole idea to have camera mapping for global illumination would be a little bit too much. Because when we think about a sphere and in the middle a camera, and we shoot one time around and we get then a texture that is in 360 by 180. So 180 is from pole to pole and 360 degrees is from start to finish, which wraps one time around the sphere. This image here, which we have discussed in the HDRI series, and I will discuss this in the panorama series as well, gives for one moment in time, for one position in time, the light. When we use a chrome sphere and we use a red camera, for example, to record HDRI from a sphere, so we get a video probe, so to say, and the sphere is moving exactly in the way the object would move in the scene, then we have maybe a chance to illuminate this with a texture, even over time. So it's not only limited to one point in space and time. But that's a lot of work, and that's sometimes not really possible, of course. However, the idea is any HDRI as an image-based lighting would do maybe a better job than this one here. But even this panorama, so to say, has limitations. Let's have a look to the sun again, or to let's talk about a little flashlight. And we all know these flashlights have a certain kind of pattern when we point this to a wall. And it has a direction. And when we photograph a flashlight from the side, we see only what the flashlight does to the environment. If we point the camera directly into the light, we get a completely different result. Or when we go in the opposite direction and we try to find exactly the highest point of reflectivity from this pattern that the flashlight gives, we get also a different picture. So also here we get from one shot in space and time only one idea how the light source would work. We do not get the characteristic that the light source has in conjunction to a space, because this flashlight here goes into space and gives something like a cone in the space, where when an object flies through, it's first dark, then it becomes brighter, and then to the border it becomes darker again. And this is not a given when we have just surfaces that has received light, and we hope then that the light will be given back to anything else. And the light giving back to anything else has, of course, then the next problem here. When we think back to our rough surface here, in the way this object gives the light back here is not part of GI in Cinema 4D, because there it is assumed that the light goes always in the same way. If we have there a little bump or something like that, it will not matter so much. We have to change the geometry really to get this done. But we have no parameters, for example, just to say we want to have a roughness there and simulate this for the GI only. And then we have maybe also a little problem with different light sources, because The sun itself is so far away that the inverse square rule from our tiny little Earth here with the little atmosphere is nearly nothing in terms of reduction of light intensity. The flashlight itself has that pretty fast, as you might know from any walk in the night. But the sun during the day, you can walk a mile up on a mountain and you will not notice any change of light there. So we have a lot of problems when you go more and more into detail with the light. So in short, we have to deal with the interaction between all these surfaces. We have to deal with the light direction that is not implemented, the missing parts of the camera projection, of course, and then the light characteristics that we miss. Further, we have to check out the surface differences when we talk about luminance and photography, and of course the reflection, which I haven't done now here because that's a longer theme, like caustics, and shadows means that we have less light in it, even if the object by itself casts this shadow. So all in all, this is a long list, and just to overcome maybe the idea to illuminate with standard lights, because that's possible and sometimes it's much faster. So before you go into it and say, okay, we do this just with camera mapping and we get the GI out of it, always keep in mind what you see in the results of camera mapping is of course the illusion of a whole space. It's mostly like in a theater. It's a stage, nothing else, but it's a great stage, of course. Thanks for listening. Have fun with it. Bye bye.